Hello, hi everyone. Welcome to the next video of this series. In this video, we are going to discuss last chapter of the organic chemistry, that is the amines. Okay, so we will be discussing some previous work questions of this chapter. Again, I have divided the entire chapter into the GOC and reaction mechanism questions. Then we will do some questions related to the physical properties and then chemical properties. Most of the questions are going to be from the chemical properties of the amines. Very easy chapter, simple chapter, and you can easily learn the reactions of amines. Okay, so let's discuss in a systematic manner. So first we are going to discuss weightage, then syllabus with the help of the mind map, and then we have PYQs. Okay, and then we will solve previous year questions. Who will benefit from this video? Who knows the basic? It means here NCERT is important. If you know NCERT reactions, then you can do most of the questions of the amines. So NCERT level knowledge is very important over here, and please revise your notes from the coaching so that you can have better clarity when I apply the same concepts in the questions. Okay, so how to use this video? Revise your short notes, write down all the information right on a piece of paper, and then you can start doing the practice. If we talk about the weightage, so one question is going to come at an average. In some sets, you can find two or more questions because there are so many questions which can be done on the basis of the GOC concepts. If you know GOC very well, if you know the concepts of the reaction mechanism very well, so you can do the questions of amines. Okay, so many questions of amines. Now let's talk about the mind map. So we have amines. So in amines, we have two types: aliphatic amines, and aromatic amines. In aromatic amines, we are going to discuss about aniline. We are going to discuss about aniline, NH2, and we have this benzene. Up now, what you should know with respect to aliphatic amines and aromatic amines, you should know basic preparation method, physical properties, physical properties, and chemical properties. Okay, chemical properties. Then we have some distinguished tests also. Okay, we have some distinguished tests, so that is also the important part over here. Okay, so here we have to do for aliphatic amines and even for the aromatic amines. That's it. Okay, so let me discuss the type 1 questions which are going to be from the basics, and in the basics means we have to apply the concept of GOC and the reaction mechanism. Okay, now moving on to the question number 1. So question number 1 says the correct order in aqueous medium of basic strength in case of methyl substituted amines. So correct order in aqueous medium of basic strength. So see, if we have the gaseous state, then basic strength is 3 degree, greater than 2 degree, then 1 degree, and then we have ammonia. Right? If we have aqueous medium, so in aqueous medium, basic strength is going to be 2 degree, 1 degree, 3 degree, and then ammonia if R group is going to be the methyl group. If R is not methyl group, then we have 2 degree, 3 degree, 1 degree, and ammonia. It's just you have to learn this in order to solve this question. Okay, so let's see. 2 degree is going to be most basic. So as per this, we have two options only, option number 1 and 2. So after 2 degree, because this is a methyl group, so we have what? 2 degree, 1 degree, 3 degree, and then ammonia. So answer is going to be option number 1. Okay? So that is 2 degree, 1 degree, 3 degree, and ammonia. Understood? That's it. Now moving on to the next question. In the following compound, the favorable site for protonation is R. For protonation means, it means we have to find out the most basic nitrogen, or the nitrogen which is more basic. So now we know that localized electrons are more basic in comparison to delocalized electron. Delocalized electron means which participates in resonance, right? Which participates in resonance. Now, if you see this nitrogen lone pair does not participate in resonance. Why? Because we have internal delocalization, right? We have internal delocalization. So B nitrogen does not participate in localization. C ka C nitrogen electron does not participate in delocalization. Okay, same with D and same with E. Okay, these electrons, they are not involved. They are not involved in the delocalization. Even if you want to see, so D है. If we have E, so E का करेंगे, so it is going to shift over here, and this electron shift, मतलब this double bond electron shifts over here. Right, then we have to delocalize this one, right? We have to delocalize this one, so it means E ka electron cannot participate in resonance. So we have how many? 4 favorable sites for protonation, because what happens? Nitrogen ka lone pair forms bond with the H plus. So favorable sites, they are B, C, D and E. A ka electron can participate in resonance. See, it can participate in resonance. Okay, so as per our option 2 is going to be the correct answer, B, C and D. Next question. Which of the following is least basic? So least basic, we know that basic strength is directly proportional to localized electron. Localized electron directly proportional to stability of conjugate acid, and directly proportional to electron releasing group, and inversely proportional to electron withdrawing group. Okay, now see option number 1. If we see option number 1, we have CH3, C double bond O, and then NH, and here we have C2H1. Okay, now if you see over here, so these electrons, they are involved in resonance. So this is going to be minus R effect. Okay, this is going to be minus R effect, and this is going to be plus sign. Now in the second one, we can have C2H5 and then C2H5 triethyl amine. So here we have electron releasing group, right? The 3 electron releasing group here. Now the third one, CH3, C double bond O, then we have NH and then C double bond O, CH3. This is electron withdrawing group and this is also electron withdrawing group. Okay, so we have 2 electron withdrawing group. Next, C2H5 2NH, 4. C2H5 2NH. So here we have 2 electron releasing group, right? Plus I and plus I. Here we have minus R, here we have minus R. Okay, so on the basis of that, which one is going to be least basic? Option number 3, due to the presence of 2 electron withdrawing group. ठीक है, 2 electron withdrawing group है, so electrons present on nitrogen, they are not available for the donation and they are not available for the bond formation with H plus, right? That's the option 3 is going to be the correct answer. Now moving on to the next question, बच्चे. In the following compounds, the decreasing order of basic strength will be. So whenever you have this kind of question, so first you have to find out the basic character with respect to gaseous state. So if we see the gaseous state, so all are aliphatic amines. And one more thing, aliphatic amines are more basic than aromatic amines. Aromatic amines. Because if we have aromatic amines, then electrons on nitrogen are involved in resonance. Okay. So gaseous state है. So in the following compounds, decreasing order of basic strength will be. So all are aliphatic amines. So we have to see 3 degree, then 2 degree, then 1 degree. Okay. Do we have this kind of option? We have this option 3. Option 3 may we have 2 degree, 1 degree, and then ammonia. Okay. So answer 3 is going to be the option 3 is going to be the correct answer. Suppose if we do not have any option with respect to the gaseous state, then we have to look for the aqueous state. Okay, next question. The increasing basicity order of the following compound. So see, here we have 2 degree, here we have 3 degree, here we have 1 degree, and this is going to be the aromatic, है ना? Aromatic, why? Because phenyl is there, so aromatic है. Aromatic amines are least basic in comparison to aliphatic amines. ठीक है, so D is going to be the least basic. Now out of 1, 2 and 3, so 3 should be the most basic if we talk about the gaseous nature. So if we see this part, so 3 degree, it means C is going to be the most basic, so we have option C, and उसके बाद we have option D, so we cannot have this answer ना. It means we have to find out the answer with respect to aqueous phase. So in aqueous phase 2 degree is going to be most basic, so B is going to be most basic, D is going to be the least basic, so we have option number 2 as the correct answer. D is going to be least basic and B is going to be most basic. Then we have A and then we have D. Moving on to the next question. Choose the correct order of basic nature of above amines. So we have to do in that way. So we have phenyl methanamine, NN dimethyl and methylaniline. So let me draw the structure of A1. Phenyl methanamine. So this is phenyl group and methanamine is CH2NH2. Okay. Then B is NN dimethyl. It means we have NN dimethyl and this is aniline. Now C is N-methyl So N-methyl Now D is benzenamine. Benzenamine is nothing, it's just aniline. So see, NH2, this NH2. So these lone pairs are not involved in resonance. No delocalization over here, right? No delocalization. So A is going to be the most basic. So we have option number 3 and option number 4. So A is going to be most basic. Now then, this is a lone pair. They are involved in delocalization in all cases. Okay. But in B we have 2 electron releasing group. In C we have 1 electron releasing group, and in D no electron releasing group. So after A, which one is going to be most basic? B, then C, and then D. So option 4 is going to be the correct answer. Okay. Now let's do next question. The decreasing order of basicity. So first we have to check the localized. So if you see nitrogen lone pair, they are localized, not involved in delocalization. Why? Because internal delocalization is already there, है ना? Internal delocalization is already there, so this is localized. Even these lone pair, they are also localized. Okay. Up now in B and C both are localized. Now check hybridization. So here nitrogen is sp2 hybridized and this is sp3. So sp3 means less electronegative. Less electronegative means can easily give its lone pair easily बच्चे. ठीक है. So it means C is going to be most basic, and then we have B. C and B. If you look for the option, we have only one which can be matched, right? Which can be matched. So C, B. Up now, but we have to understand the other options A and D. So see, here A, lone pair are involved in delocalization. Here also lone pair are involved in delocalization. So what we are going to say, we have to check the stability of for A and D. For A and D, let me move on to next page. For A and D, check stability of conjugate acid. So this is aniline, NH2. So when it forms bond with the H plus, so we get NH3 positive. So this is aromatic only, right? This is aromatic. Huckel's rule, if you follow Huckel's rule, so this is 4n plus 2 is equal to 2, 4, 6, right? 6, and n ka value comes out to be 1. But if we have this NH, so when it forms bond with H plus, then we have this H positive. Now if we apply this, the 4n plus 2 is equal to 2 and 4. So 4, the 4n is equal to 2 and n is equal to half. So it means this is anti-aromatic. So the stability order is aromatic. Then we have anti-aromatic, not anti-aromatic. Then we have non-aromatic, and last we have anti-aromatic. So this is the stability order. ठीक है. So it means after B, stability, the basicity is going to be A. A basicity is going to be what, and then we have B. Okay. Now next question, arrange the following amines in the decreasing order of basicity. Again, so see, localized, this is localized. Here sp2, here sp3. So third is most basic, then we have first, and then we have second. ठीक है. So third, first and second. So option 2 is the correct answer. Okay. Now next question, pKb value. So basic strength is directly proportional to the Kb value and inversely proportional to the pKb value. So first we have to find out the Kb. So Kb is going to be more for, so see, N dimethyl है ना, and we have OCH3 which is the electron releasing group. Here meta position oxygen is more electronegative, so here we have minus I effect. Same Cn we have minus I effect. Okay, so the most basic is going to be first one, then we have second one. Now third and fourth may we have to check the minus I effect. So minus I effect of Cn is more than OH. So it means D fourth is going to be more basic in comparison to the third one, right? Because basic strength is directly proportional to electron releasing group and inversely proportional to electron withdrawal. So what is the order of pKb? pKb is going to be first ka less, then second, then fourth, and then third. So as per this, option 2 is going to be the correct answer. Okay. Now let's do next question. The increasing order of pKb, again we have to apply the same concept again. So here we have double bond NH. So if you see over here, so electron density on this nitrogen increases. Similarly, we can increase electron density on this nitrogen, right? And we can increase electron density on this nitrogen. So here we have two electron releasing group, but both plus I effect, right? Here we have plus R effect. In both we have plus R effect, so 2 plus R effect. And here we have 1 plus R effect. So plus R effect, resonance is more dominating in comparison to inductive effect. So B is going to be the most basic, that's the order of Kp. Then we have A, and then we have C. Now pKb order is going to be reversed. So this is B, A, and C. So option 4 is going to be the correct answer. Okay. Now next type of question is based on physical properties. So in this, obviously memory based, right? Some part is memory based, and then if we have boiling point, melting point, then you can relate it with the hydrogen bonding. So question once, statement one said, pure aniline and other aryl amines are usually colorless. Yes, it is true. Generally, they are colorless. Aryl amines like we have aniline. Okay, so they are aryl amines ARNH2. Get colored on storage due to atmospheric reduction? No, due to atmospheric oxidation. Yes, they get colored due to atmospheric oxidation. So this statement is false. So we can say that statement 1 is correct and statement 2 is incorrect. So this question is completely on memory. So this is memory based question. Okay, that's it. Let's do some questions which are based on the distinguished test. It means there are some tests which we use to distinguish 1 degree amine from 2 degree amine and 3 degree amines. So we have to use these tests, and we have to know the chemical properties of the amines in order to get the right answer. Okay, so let's do question number 1. Question 1 says ki we have compound P. P has certain molecular formula, that is C14H13O and nitrogen. Okay, P C14H13O and nitrogen. That is the molecular formula of P. Then P on reaction with HCl and heat gives some product. On filtration we get Q, which is in the residue, and in the filtrate we have some product. Filtrate on reaction with NaOH gives oily liquid R. Now let us find out what are the other information given to us. So compound P is neutral. It means this is neutral. Compound gives effervescence with NaHCO3. If it gives effervescence, effervescence is due to the formation of CO2, then Q must be acid, right? It must be acid. While R reacts with Hinsberg reagent, this R, it reacts with Hinsberg reagent to give solid soluble in NaOH. So it means R must be amine. So amine can react with Hinsberg reagent, and if the sulfonamide is soluble in NaOH, it means that amine is going to be 1 degree amine. 1 degree amine. Okay, fine. So it means we have to look for that compound which on hydrolysis, because HCl है heat है, so we can say कि this is मतलब its purpose is hydrolysis. So which on hydrolysis gives acid and amine. So let's do this. So here though we do not get acid and all, right? We do not get acid. So either though no. But if we look for this one, we have amide. So let's do the hydrolysis of amide. So on breaking this, here we write H because nitrogen is delta negative, electronegativity is more. Then here delta positive. So here we have OH. So from second one, we get benzoic acid plus we get this NHCH3. This is 2 degree amine. So this cannot be answer. Okay, similarly, let's look for this one. So here we get carboxylic acid OH, but here we get ammonia. So we cannot have this. Let's look for option number 4. So on hydrolysis, we get OH over here and H over here. So we get aniline. So aniline is what? 1 degree, and we also get carboxylic acid, which gives brisk effervescence on reaction with NaHCO3. It means our answer is going to be option number 4. Okay. Now, next question. Next question says that isomeric amines with molecular formula C8H11 nitrogen gives the following test. So, P isomer can be prepared by Gabriel thalamide synthesis. If P isomer can be prepared by Gabriel thalamide synthesis, then that is going to be 1 degree amine. Okay. Now, Q reacts with Hinsberg reagent, but the product is insoluble in NaOH. It means it is going to be 2 degree amine. Third, reaction with HNO2 followed by beta naphthol in NaOH to give red dye. So R. So here we can say coupling reaction happens, right? So for coupling reaction, we should be having aromatic 1 degree amine. Aromatic 1 degree amine. Okay, aromatic 1 degree amine, it means we should be having a aryl amine. So we have to look for that option. So this is 1 degree, this is 3 degree. No, this cannot be the answer. Now look for second. This is 1 degree. This is 1 degree. No, it cannot be answer. This is 2 degree, cannot be answer. This is 1 degree. Okay, this is 2 degree amine. Nitrogen is bonded to 2 carbon, and this is 1 degree aromatic amine. Okay, so this is the answer. Let's do the last reaction. Reaction is reaction with HNO2 followed by beta naphthol. It means if we have suppose NH2, right? If we have NH2 and here we have this. So on reaction with HNO2, we get N2 plus over here. Okay? On reaction with beta naphthol, right? Beta naphthol is this OH. Okay? So coupling happens at ortho position. Generally coupling happens at para position, but here para position is not free. Para position is already occupied. So here coupling happens at ortho position. So we are going to get this product OH, and here we write N double bond N. Then we have this. Okay. So this reaction ko matlab we can get the dye na after coupling reaction, so we get azo dye. This is azo dye. Why? Because we have nitrogen bond. Clear? Now, let's do next question. Region 1 ethylamine and sulfonylic acid in acetic acid is used for the detection of. So the answer of this question is NO3 minus. Okay. So this is actually not NO3 minus, it is NO2 minus, right? So what happens? NO2 minus in the presence of acetic acid. Okay, NO2 minus takes H plus and forms HNO2 and we get CH3COO minus. Now we have sulfonylic acid. ठीक है, सल्फेनिलिक एसिड में NH2 and we have SO3H. ठीक है बेटे. So now what happens? This is an acid now and this is the base. Okay, so NH2 has base, so we are going to form this NH3 positive and CH3COO minus. Okay, so we are going to get this kind of salt. Understood? We are going to get this kind of salt. Now what happens in the presence of HNO2? It forms N2 plus over here, right? It means this part is converted to N2 plus, this complete part. Now we are going to do coupling reaction. So we have N2 positive and here we can say we have SO3 minus or we can say SO3H, whatever, right? So in the presence of let me write SO3H only, N2 positive in the presence of 1-naphthylamine. 1-naphthylamine. So 1-naphthylamine is this NH2. So coupling happens at para position. So para position is free. So we get NH2 and at para position we are going to do coupling. Okay. So this is used to detect NO2 minus because NO2 minus provides HNO2 which helps in the coupling. Okay, which helps in the coupling. Is it clear? Okay. Now moving on to the next question. We have Hinsberg reagent, that is benzene sulfonyl chloride. Okay, Hinsberg reagent is what? Benzene sulfonyl chloride. So option 3 is the correct answer for that. Now next question. Three isomers A, B and C give the following result. A and C undergoes diazotization. It means 1 degree arylamine. 1 degree arylamine. So we get P and Q. Now after hydrolysis and oxidation with KMnO4H plus, we get R, which is the product of A, and S, product of C. Fine. R has lower boiling point than S. B, C6H5SO2Cl, alkali insoluble product. So it means B can react with Hinsberg reagent, but it gives the insoluble product with the NaOH. So this must be 2 degree. So first though, in order to identify B, we have option number 2 and 4th, right? We have option number 2 and 4th. So if we have option number 2 and 4th, so let's check option number 2. Okay. So now if this is A, so after diazotization, we have N2 positive and CH2CH3. Now after hydrolysis and oxidation, we get COH, right? And hydrolysis we can say ki we are going to react this with H2O, right? H2O in the presence of H plus. Okay, bete? So we get this COOH. Okay, bete? Or we can say OH. Ab now if we have this one CH2CH3 and here NH2. So after diazotization and hydrolysis and oxidation, we are going to get this one. Fine. Up now, this must be R. Why? Has lower boiling point than S. Why? Because here we have intramolecular hydrogen bonding. So if we have intramolecular hydrogen bonding, so boiling point is less. But in this S, we have intermolecular hydrogen bonding. So if we have intermolecular hydrogen bonding, so we get the boiling point is going to be more. So it means we can say option 2 is going to be the correct answer. Okay, that's it. Okay, fine. Now let's do next question. Primary, secondary and tertiary amines can be separated using. Para-toluene sulfonyl chloride. This is also known as tosyl chloride. So this is SO2, Cl and para-toluene. Okay, so it can show similar kind of reaction like Hinsberg region 2. So we can separate primary, secondary and tertiary. Okay, now next, consider the following reaction. P, NaNO2HCl0, beta naphthalene NaOH colored solid. It means coupling happens. Coupling happens and azodine forms. Okay, now Br2H2O के साथ we get 3 bromine. It means ortho and para position should be free. Para position should be free. Should be free. And in P, we must have electron releasing group. It's just we have to find out this thing in order to get the correct answer. Okay. So if you see option 3, so NH2, it's an electron releasing group. So NH2, and we have CH3 over here. So in the presence of Br2 water, we get on ortho Br and on para we get Br. Okay. Now then we can do the coupling. In the coupling, what happens? HNO2 reaction with the HCl, or we can say HNO2 reaction, just write the reaction with HNO2. So we get N2 plus, and here we have CH3, and we have then beta naphthol. So beta naphthol is this 2 hydroxy naphthalene in the presence of OH minus. So we are going to do coupling. So when we do coupling, so coupling happens at ortho position. Why? Because para position is not free over here. So we write N double bond N, and here we have benzene, phenyl ring, and at meta position we have CH3. Clear? So answer is going to be option number 3. Now, next question. An organic compound A on treatment with benzene sulfonyl chloride gives compound B. B is soluble in dilute NaOH. It means that is 1 degree amine. 2 degree amine is insoluble in NaOH, and 3 degree amine does not show any reaction with the Hinsberg region. So we have to identify the 1 degree amine. So see, this is 2 degree amine, this is 2 degree amine, this is 2 degree amine, this is 1 degree amine, because nitrogen is bonded to 1 carbon. So option 4 is the correct answer. Clear? Option 4 is the correct answer. Now, next question. Carbylamine is used to detect the presence of primary amino group. Right, if we have RNH2, so on reaction with CSCl3 and KOH, alcoholic KOH, so we get RNC, false smelling compound. False smelling compound. And this is the test to distinguish 1 degree amine. So question says, which of the following compound is formed when this test is performed with aniline? So if aniline hai ARNH2, so we get this NC. Okay, so option 2 is the correct answer. Okay, now next question. A compound X on treatment with Br2NaOH provided C3H9N, which gives positive carbylamine test. Positive carbylamine test means 1 degree amine. And if we get 1 degree amine, it means Br2NaOH. This is a region for Hoffman bromamide degradation. So what happens over here? If we have RCONH2, so in the presence of Br2OH minus, we have to remove this CO and we are going to put RNH2. Okay? And this CO, and if we have suppose KOH, so we get K2CO3 plus KBr plus water. So these are the byproducts. So some questions are there on the basis of byproduct. So the point is that we should be getting 1 degree amine. So we have to look for that one. Okay? So on treatment with this, so we should be having amide. So if you see option number 3, so option number 3 is CH3, CH2, CH2, C double bond O NH2. So on reaction with Br2OH minus bache, we have to remove this, and when we remove this, so we get CH3, CH2, CH2, NH2, and this is 1 degree amine. And this is 3C3H 3, 4, 5, 6, 7, 8, 9, H9 and nitrogen. So option 3 is the correct answer. Okay. Okay. Now we are moving to the last type, in which we are going to discuss so many questions related to the chemical properties of amines, aliphatic amines and aromatic amines. So let's do the question number 1. So question number 1 says the major product A and B from the following reactions are. So major product A and B from the following reactions. So see, this is NH and C double bond O this. On reaction with LiAlH4, what we are going to do? This is amide. So amides are reduced to amines, right? These are reduced to amines. So we get NH, CH2, CH3. Okay, NH, CH2, CH3. So this must be option B. This must be option B. So we have this only, right? And Br2ACOH. So Br2ACOH means Br2 in the presence of acetic acid. So we have to do electrophilic aromatic substitution. So this is electron releasing group. So in the presence of acetic OS, we get Br on para position. We get Br on para position. Okay. So on the basis of that, option 3 is the correct answer. Okay. Now let's do next question. The major product formed in the following reaction is, okay, so we have this CH2, C double bond O, NH2, and here we have C double bond O, OCH3. Okay, so first Br2NaOH, Br2NaOH heating. So this is Hofmann bromamide degradation. So from this we get amines from amide. So we have to remove the CO and we are going to put CH2, NH2. Okay, C double bond O, OCH3. Now what happens? Intramolecular attack will happen. Okay, intramolecular attack will happen because this is the electrophilic center and on nitrogen we have lone pair. So this attacks over here and OCH3 leaves. Okay, so we get CH2 NH positive and this is C double bond O this. Now OCH3 minus takes H plus, an electron of this bond nitrogen hydrogen bond shifts to nitrogen in order to neutralize the positive charge. So we get CH2 NH and double bond O this. Okay. So from this, option B is going to be the correct answer. Now next question. Next question. We have this N2 plus and Cl minus reacted with reagent in list 1. Okay, this is list 1 to form product in list 2. Okay, so N2 plus and Cl minus. So this is the benzene diazonium chloride. Okay, benzene diazonium chloride. So on reaction with aniline, we will have coupling reaction and we get the azodie formation and the product is going to be this N double bond N. So coupling happens at para position of this aniline, yani at this position. Okay, so we get this formation. So A can be matched with third. Now second, if N2 plus Cl minus reacts with HbF4, so we get fluorobenzene. We get this one. So B can be matched with first. Copper HCl, this is the Getterman reaction. So HCl है. So we form chlorobenzene. We can form chlorobenzene. So C can be matched with fourth and D can be matched with second. CuCN and KCl. So on the basis of that, let's find out the correct answer. A third, B first, C is fourth and D is second. So on the basis of that, fourth is going to be the correct answer. Okay. Now let's do the next question. We have orthophenylene diamine. Orthophenylene diamine, it means we have NH2 and NH2. On reaction with HNO2, what happens? We are going to form benzene diazonium salt. So we get N double bond and this. Okay, bete? We have NH2. Now what happens? Intramolecular attack is going to happen. So this nitrogen lone pair attacks over here and electron of this bond shifts to nitrogen. Intramolecular attack is always faster than the intermolecular attack. So this NH2 cannot be converted to N2 positive. Okay, so we get N double bond N. Here we write NH2, right? Or further loss of H plus is going to happen, so we get NH. ठीक है बेटे, so option 1 is going to be the correct answer. Clear? Now next question. Next question. NaNO2 and HCl. But if you see this, we do not have NH2 and we do not have aniline, right? So it means NaNO2 plus HCl gives HNO2. HNO2 plus NaCl. Now HNO2 in the presence of acidic medium, what happens? Removal of H2O. So when H2O, we remove H2O, so it means we are going to form NO positive. So here we do electrophilic aromatic substitution, but with respect to OH, because here we have plus M effect and that is a dominating effect. So at para position we get NO group. Okay, bete, NO group. Now we have NH4SH. So this is NH3 plus H2S. So this is going to be the reducing reagent. And what is the purpose of this? This NO is converted to NH2. Okay, bache. So final reaction, final product is going to be NH2 over here. This is OH and we get this as the product. So option A is the correct answer. Okay. Now next question. We have this NMe double bond O, this. First is OH minus and then heat. So what we are going to do? OH minus. So it will do nucleophilic addition reaction. Yeah, it will do nucleophilic addition reaction because we have carbonyl carbon, we have amide now. So nucleophilic addition elimination reaction, which we can write as nucleophilic substitution reaction, है ना? We can write nucleophilic substitution reaction only. So OH minus attacks on this carbonyl carbon, electron of this bond shifts to this nitrogen. So from here we get NMe, here negative, then double bond, एक मिनट, double bond O and this is OH. Now in the presence of H plus, what happens? We get MENH, then CH2, CH2, CH2 and then COOH. Okay, so we get this as the product. So let's look for the correct answer. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. Option 1 is the correct answer. Clear? This can be solved on the basis of reaction mechanism concept. Now next, A, Br2CS2, NaNO2, HCl, H3PO2 and we get this one. Okay, what is the role of NaNO2? So C must be benzene diazonium chloride. Okay, here we must have this. C should be this. Br, Br, Br. Then on reaction with H3PO2 and heat, N2 plus is replaced with hydrogen. Okay, now N2 plus Cl minus, right? So B must be aniline, right? Here we should be having NH2. So Br, Br and Br. This is B. Now A, Br2CS2 0 to 5 degrees Celsius. Basically, this is the region. So generally we can say Br2CS2. So what we can write? We should be having aniline as the correct answer. Okay, because if we have anilines in the presence of Br2CS2 या फिर Br2 in the presence of water, we get ortho and para पे Br. Now 12th, next question. So NH2, NaNO2 0 to 5 degrees Celsius. So we are going to form diazonium N2 plus. Then this is a NN dimethyl aniline. So reaction with NN dimethyl aniline. so we have to do coupling, है ना, we have to do coupling, and coupling happens at para position. So this is the para position, so coupling happens at this position. So after coupling, what do we get the product? So product is this, and CH3 CH3 and double bond N, and here we have benzene. So on the basis of that, what is the correct answer? Option 3 is the correct answer. Clear? That's it. Now next question, CH3NO2, and we get this. Okay, CH3 to COH. This can be converted in the presence of KMNO4 heat. So from CH3 is converted to COH. ठीक है? NO2 meta position, we get Br. So it means we have to do electrophilic aromatic substitution. Then NO2 group must be reduced to NH2. So for that we require reducing agent. Then NH2 must be converted to N2 plus Cl minus, that is in the presence of HNO2 0 to 5 degrees Celsius, and then N2 plus Cl minus must be converted to Cl. So for that we can use Cu2Cl2 HCl, or we can simply use CuCl also, right? Or we can use CuHCl. So we have to find out the correct answer. So first meta position, so NO2 group must be there. The first step is to do the electrophilic aromatic substitution. For that we should be having Br2Fe, right? So first step ke liye we should be having Br2Fe. So when we have Br2Fe, let me write this over here. So we have CH3 and this is NO2. So in the presence of Br2Fe, or we can write Fe in the presence of, or sorry, Br2 in the presence of FeBr3. So at meta position, we will have electrophilic aromatic substitution. Okay. Or we can say ortho position to this. है ना, ortho position to this. So electrophilic aromatic substitution happens with respect to electron releasing group. So at ortho position we get Br. Okay बच्चे. Now next step. Then what we can write? We can write FeH plus. So CH3 Br NO2 group is reduced to NH2. Then we can say Br2Fe FeH plus, then HNO2 CuCl, right? So HNO2 and then CuCl, we get this CH3 Br and Cl, and after that we have KMNO4. So we get carboxylic acid. ठीक है? So this is going to be the correct. We cannot have KMNO4 in the starting. Why? Because if we have KMNO4 in the starting, the first step is to convert CH3 to COH, right? Now COH is electron withdrawing group, so Br comes over here, right? Br comes over here, not to the meta position of NO2 group. So this cannot happen, right? This part we cannot do. Clear? That's it. Fine. Let's do next question. Choose the correct color of the product for the following reaction. So we are going to form azo dye, right? So first N double bond N, and we have O C double bond O CH3. This is the leaving group. So lone pair. So lone pair comes over here, and electron of this one trips, or we can say the leaving group leaves. So we get N2 positive. Okay, bache. Now with the reaction of one naphthylamine is this. So para position is free. This para position is free. So if para position is free, so coupling happens at para position. We have to do coupling. So on coupling we get product, right? And the product is going to be this NH2 and this N double bond N SO3H. Okay, so when we have naphthylamine, so the color of the dye is red. The color of the dye is red with naphthylamine. With aniline, color of the dye is yellow, and with phenol, the color of dye is generally orange or orange red. Okay, bete. Just you have to learn the colors. ठीक है बेटे? So here option C is the correct answer. Now next question. ठीक है? So we have Me and NO2. First is the Br2. Br2 obviously it should be given कि Fp है. So electron we have to do electrophilic aromatic substitution but with respect to methyl group. So here we put Br. Okay बच्चे. Now SnHCl. तो SnHCl is reduce मतलब is used to reduce NO2 group to NH2 group. Okay, NH2 group. Then we have NaNO2 HCl 0 to 5 degrees Celsius. So we get benzene diazonium chloride. We get N2 plus Cl minus. This is C. Now this Me and we have Br N2 plus Cl minus the C on reaction with H3PO2 and water. H3PO2 and water N2 plus is converted to hydrogen. ठीक है? So we have MEBRH. Then KMNO4 KOH and H3O positive. KMNO4 KOH and H3O positive. So methyl group is converted to carboxylic acid. Okay, bete. So this is D and this is E. We have to find out A and E. So what is A? A is this and E is COH and Br. So this is E and A is this. So option 2 is the correct answer. Now let's do next question. The diazonium salt of which of the following compounds will form a colored dye on reaction with beta naphthol in NaOH? Beta naphthol is this. This is beta naphthol. 1 or 2. 2 pe we have hydroxy. So it means color dye we should be having coupling reaction. For coupling reaction we must have N2 plus Cl minus and this is formed from 1 degree aromatic amine. So we have to look for 1 degree aromatic amine. So 1 degree aromatic amine is this. Okay. मतलब NH2 should be directly bonded to benzene. Then only it happens. So option 3 is the correct answer. Okay. Now next question. Benzene diazonium chloride on reaction with aniline. Simple coupling reaction. Benzene diazonium chloride on reaction with aniline. So with reaction NH2, reaction can happen in mild acidic medium or in basic medium. It can happen. Okay, para position is free. So what we are going to write? We are going to write N double bond N and here we write NH2. So this is option 3 as the correct answer. Right. Now next question. Coupling of benzene diazonium chloride with 1 naphthol. 1 naphthol is this. So here para position is free. Para position is free. So coupling happens at para position. So we should be having third as the correct answer. Para position पे we are going to do coupling बच्चे. ठीक है. Now next question. Aniline dissolved in dilute HCl react with sodium nitrate at 0 degrees Celsius. This solution was added dropwise. It means we are going to form N2 plus Cl minus. A question says now this solution is added to the equimolar mixture of aniline and phenol in dilute HCl. Obviously we have to do coupling. Now with aniline, coupling happens in the presence of mild acidic medium. But with phenol, basic medium is required. What basic medium is required? Okay, so it means we have to do coupling with respect to aniline. And when we do coupling with respect to aniline, so option 3 is going to be the correct answer. Okay, here we have done enough questions of this type. Okay, now let's do next question. So what will be the major product in the following mononitration reaction? So see, this is electron releasing group and this is electron withdrawing group. So electron releasing group activates the ring towards electrophilic aromatic substitution. Why? Because it makes the ring nucleophilic, so it can easily attack on electrophile. ठीक है, so we have to do the electrophilic aromatic substitution with respect to this NH. So at para position we are going to attach NO2 group. Here we are going to attach NO2. So on the basis of that, option 4 is going to be the correct answer. Clear? Simple question, no? We have so simple questions with respect to aniline or amine salapar. Now again we have the question on electrophilic aromatic substitution. So you should know when aniline undergoes nitration, so we get para, meta and ortho. Para highest, then meta and then ortho. Para 51, around 51, meta around 47, and this is around 2%. Why this happens? Because in the presence of acidic medium, because this is a base, okay, in the presence of strong acidic medium, nitrogen lone pair forms bond with H plus. So when this happens, we have anilinium ion. Now this NH3 positive, it becomes electron withdrawing group. So if it becomes electron withdrawing group, so it shows electrophilic aromatic substitution at meta position. Clear? So that's why we have para, meta and ortho all. So ortho is going to be 2%. So answer is, this is para. एक में बेटे. This is para, this is meta, and this is ortho. So this is CBA. Answer is 4. Option 4 is the correct answer. Okay. Now next question. The major product A and B for the following reactions are respectively. So KC and DMSO. It means it shows SN2 reaction. So if it shows SN2 reaction, so we should be having double bond, and here in the place of I we write C. Okay. Now H2 palladium, reducing agent. So it reduces cyanide to CH2 NH2. So we get double bond O and then CH2 NH2. Okay, bache. So option 2 is the correct answer. Clear? Now, next question. Which of the following is not a correct method of the preparation of benzylamine from cyanobenzene? Cyanobenzene is this, and we have to prepare CH2NH2, benzylamine. So question says which is not the correct method. Okay. So if we use H2 nickel, we get. So this is the true, but we can prepare. With LiLH4, yes, we can do this. With LiLH4 also, we can do this. Okay. Then we have SnCl2 plus HCl gas. So SnCl2 HCl gas means it shows partial reduction. What? Partial reduction. Partial reduction. So we get Cl double bond NH, imine. Okay, and in the presence of NaBH, imines are reduced in the presence of NaBH. So NaBH4 can reduce imines. What are imines? Imines means carbon nitrogen double. Okay, so it means this is also true. So which is left? Fourth. Fourth is not true. So fourth is going to be the correct answer. So just try to understand. We have Cl and we have HCl in the presence of pani. It means hydrolysis. Hydrolysis of this gives carboxylic acid, right? Or suppose if we have to do partial, so we get this amides. Now they are not reduced in the presence of NaBH. Not reduced. Okay? Not reduced. So option 4 is going to be the correct answer. Clear? Now, moving on to the next question. The major product A and B in the following reactions are. So, peroxide heat. It means we have to form free radical. Then A on reaction with this, we get B. Okay. So now we have to form free radical. So see. Here we have hydrogen. Here C triple bond N. ठीक है. If I remove hydrogen from here, so we get free radical over here, but this free radical is in the presence of electron withdrawing group unstable, right? Unstable. So what we are going to do, we are going to form free radical over here. Then we have 3-degree free radical. This is also 3-degree, but it is with electron withdrawing group. So this is, on this carbon we will have free radical. This is also 3-degree, which is stable, more stable. So A is going to be this, A must be this. Okay, now what happens, we have to react this free radical with this alkene. So let me write this down. This is Cn, and we have free radical over here, and we have alkene 1, 2, 3, 4, 5. Pentene 1, 2, 3, 4, 5. Okay. Now how to do this one? So this is the free radical thing, right? Free radical one. So it's just we have to do attack. Now electron of this bond shifts to this second and this. Okay, bache? Clear? So it means we have to join. We have to join, na? We have to join. Fine. So we have to join with number 2. We have to join with 2 number, because this is the 2-degree free radical, na? 2-degree. So here, so I can, from this, from 1 we can join with hydrogen. Okay, then we get 2-degree free radical, which is more stable. So we have to join this. So let's join this. Okay. So on the basis of that, we get 1 minute. Fine. 1, 2, 3. Now on second position, this is second number, this is 1 number, this is 3 number, this is 4 number, this is 5 number. We have joined this. This is bonded to 2 methyl group. Then we have this here, Cn, and this. Okay, so let's see. We have 1, 2, 3, 4, 5. Then this. Okay, fine. Option 1 is going to be the correct answer. Clear? Now, next question, CH3, CH2, Cn, HCO positive and heat. So it means complete hydrolysis. Okay, complete hydrolysis. So if we do complete hydrolysis, we get CH3, CH2, C double bond O, OH. Then SOCl2. So OH is converted to Cl. So we write CH3, CH2, C double bond O, Cl. Then PD, BaSO4 and H2. So this is Rosenmund reduction, hai na? Rosenmund. So from acid chloride we get aldehyde, CH3, CH2, C double bond O, H. So option 2 is the correct answer. Okay. Now next question. Fine, we have Cn and 1 minute, let me rewrite this. So we have this C triple bond N, we have OCH3, this, and we have first C6H5MgBr dry ether, and we have only one equivalent. So what is the function of this? Nucleophilic addition, because we do not have acid over here. So nucleophilic addition. So delta positive, delta negative, delta negative, delta positive. So it means this phenyl group forms bond with this, electron of this bond shifts to nitrogen, and nitrogen forms bond with MgBr. Okay, so on doing so we get C6H5 double bond N MgBr, and here we write OCH3 and this. Then we have to do hydrolysis. So on hydrolysis, what we are going to do, we are going to break this bond. So as nitrogen is more electronegative, so we write 2H hydrogen with nitrogen and 2OH with this carbon. So we get COH, OH, C6H5, OCH3 and this. Clear? Let me rewrite this. We get C6H5, OH, OH, OCH3 and this. Now 2 OH are unstable on one carbon. 2 OH are unstable on one carbon. So rapid loss of water. So we have to remove water. So let's remove water. So we get C double bond O C6H5, OCH3 and this. Clear? So let's find out the correct answer, bache. We have option number 4 as the correct answer. Easy? Okay, let's do next question. We have CN. Okay, 2 times we have to do hydrolysis. It means first we have to do partial hydrolysis. So partial hydrolysis means let's break one bond. So when we break one bond, as nitrogen is more electronegative, so here we write H and here we write OH. So on partial hydrolysis, we get COH, double bond NH, which on tautomerize gives amide NH2. So this is A. And then on hydrolysis, this on the amides on hydrolysis gives carboxylic acid. So we have to find A, hai na? So A is what? This option 3. Right? Option 3 is going to be the correct answer. Now next question. Reaction of propanamide. Propanamide. It means CH3, CH2, C double bond O, NH2 with Br2KOH. Okay, Br2KOH. This is Hoffman bromamide degradation. We have to remove this. So it means we get CH3, CH2, NH2. 1 degree amine, 1 carbon is less. So we get ethyl nitrite. Not ethyl nitrile, ethyl amine. Okay, ethyl amine. Nitrile is CN. Nitrile is this. So we get 4th, ethyl amine. Okay. Now let's do this reaction. We have to match with the correct name reaction. So see, we have CH3Cl and Na and chlorobenzene. So this is Wood's fatigue, है ना? First reaction is Wood's fatigue. RX, ARX. In the presence of Na, dry ether. So we get R and AR. Okay. Then second B. B is only fatigue. 2 molecules of chlorobenzene. So that is fatigue. So B can be matched with first. So A, second B first. Third N2 plus Cu2Cl2. Sandmeyer. Fourth. Right? Fourth. And then iodide. We have prepared iodide. So this is going to be Finkelstein. So D is going to be third. So let's match A second, B first, C fourth and D third. So option 4th is the correct answer. Okay. Now let's do next question. Question says consider the reactions. Consider the reactions and we have to find benzyl cyanide can be obtained by benzyl isocyanide. Benzyl isocyanide is this CH2NC. So from which compounds we can prepare? Okay. So if we have AgCN, so AgCN means Ag and this C triple bond N. So nitrogen ka lone pair is going to attack on this CH2Br. So we have nucleophilic substitution over here. So this reacts over here and Br leave and we get CH2NC. With that we get AgBr. So from this so we can prepare. So A is the answer. That can be prepared. So from this we can prepare. Then we have CHCl3 aqueous KOH. Okay. So fine. So CHCl3 generally we should be having alcoholic KOH, right? Alcoholic KOH should be there, but aqueous KOH so we can do this one. So we write CH2NC. That's a carbylamine reaction. Okay, carbylamine reaction. So 1 degree amines can show carbylamine reaction. So this is 2 degree. So no carbylamine. KCN hai, so we can do nucleophilic substitution, but here carbon is going to attack. So we get cyanide. We get cyanide. So answer is going to be A and B. We will look for the options, right? A and B. Now, next question. In the above conversion of compound X to product Y, the sequence of reagents to be used will be. Okay, fine. So CH3 remains CH3, NO2 At the position of Na2, we have hydrogen, and at ortho position we have Br. Okay, fine. So what we are going to do, ठीक है. So if we look for the region, so if we see Br2 Fe, so FeBr2, if it do electrophilic aromatic substitution, but that is with respect to CH3 because it's an electro-reducing group. It activates the ring towards electrophilic aromatic substitution. So we should be having Br at ortho position, right? So we have this group. So no, first option is incorrect. Now let's look for second one. So second one ka to nothing. Third one FeH plus. So FeH plus. So CH3 NO2 is converted to NH2. Fine. Then we have Br2 water. So on ortho position and para position we get Br, right? We get Br. Para position is not free, so we get Br at 2 ortho position. Fine. Then we have HNO2. So HNO2, NH2 is converted to diazonium chloride. Okay, bete. N2 positive. And then we have CuBr. So this is, we get, and in place of N2 plus, we get Br. No, so this is also incorrect. So we have option number 4 as the correct answer. FeH plus, Br2 equals HNO2 and H3PO2. Because if we have H3PO2, so in the presence of H3PO2, we get Y. Clear? That's it. So answer 4th, option 4 is going to be the correct answer. Now let's do this question. So we have NO2 in the presence of H2PD and we have alcohol over here. So reducing agent, so NO2 is converted to NH2. Then we have anhydride, acetic anhydride in the presence of pyridine. So what is the role of pyridine? Pyridine is this. It is a base, so it's abstract hydrogen, right? So when it abstracts hydrogen, so we get this NH negative. Now this is going to be a nucleophile. So we are going to perform nucleophilic addition reaction and this part. So we get NH C double bond O CH3. Okay. We get NHC double bond O CH3. This reaction is also used to protect amino group. Okay, so option 4 is the correct answer. Now, next question. How many of the transformation given below would result in aromatic amines? So, see, first reaction is Hofmann bromamide degradation. So, we have to remove this. So, we get NH2. So, this is 1 degree aromatic amine. Okay, aniline 1 degree aromatic amine. Now, this reaction is Gabriel phthalimide synthesis. Gabriel phthalimide synthesis is also used to prepare 1 degree amine, but not aromatic. Aromatic and bulkier group should be absent. Bulkier group should be absent in halide part. So no reaction. In second one, no reaction. Okay. Now let's check for third. So that's a reducing agent. So in place of NO2 we have NH2. So 1 degree aromatic amine, yes. Then dilute H2SO4. So we are going to do hydrolysis. Okay. So in hydrolysis, what we are going to do? We are going to break the amide linkage as nitrogen is more electronegative. So we are put H plus over here and here we put OH. So we get NH2 plus CH3COH. So how many of the transformation given below would result in aromatic amines? So answer is going to be 3. A, C and D. Okay, 3. Now next question. In the following reaction, A is A. So see, we have NH2 and CH2OH. OET double bond OET. Okay, fine. So now we have nitrogen has lone pair, even oxygen has lone pair, right? But nitrogen is less electronegative, so it can give its lone pair easily. So it's a better nucleophile in comparison to OH minus. So it attacks over here and OET leaves. Okay, bache. So from this, we are going to write this NHC double bond O OET and then CH2OH. Now, see, we have a leaving group over here. So now oxygen can attack over here and OET leaves. So by doing so, 1, 2, 3, 4, 5, we will have 5-membered ring formation. Okay. So we get NHO. Here we write CH2, C double bond, C double bond O, and CH2O. Clear? H plus is going to remove. We are going to remove H plus later on. ठीक है बेटे? So what is going to be the correct answer? Option 2 is going to be the correct answer. We are going to remove H plus. OET takes H plus. Okay. If I'm going to write completely, so first what I'm going to write here, we have OH positive. Now what happens? What happens? OET minus takes this hydrogen and electron of this bond shifts to oxygen, results in the formation of second product. Okay. Now next question, the major product in the following reaction is. So we have CH3I. So nucleophilic substitution we have to do. Okay, nucleophilic substitution we have to do. So nucleophilic substitution means we have to find out which one is better nucleophile. Better nucleophile के लिए we should be find out localized electron and can give electron easily. Okay, can give electron easily. We have discussed similar kind of questions in this chapter only when we were discussing GOC questions. So see, these are localized. All electrons are localized, है ना? These are localized one. Does not participate in hydrogen. Does not participate in resonance. So this is sp2, this is sp2, this is sp3, and this is sp2. So this can easily give electron, है ना? Can easily give electron. Can easily give electron. So it means what happened? Nitrogen, this nitrogen lone pair attacks on CH3 and iodine removes. We are going to remove iodine, right? So we are going to get option 4 as the correct answer. Clear, bache? That's it. We have in the presence of base na, so what is the role of base first? So like we have N, double bond and N. So role of base is ki first hydrogen abstraction. So we get this. Okay? Okay? And this is NH2. And then it attacks on methyl group and iodine leaves to get option number 4 as the correct answer. Means we can get the option number 4. Now let's do the next question. Which of the following reaction will not give para-amino-azobenzene? Para-amino-azobenzene means para-amino-azobenzene. We should be getting this one. For that, we must have benzene diazonium chloride, है ना? Benzene diazonium chloride and aniline. So see, aniline is there. Aniline is there. Okay. So question says which of the following will not give para-amino-benzene? So see, SnHCl से NO2 group is converted to HNO2. Then HNO2 से we get N2 plus Cl minus, and in the presence of aniline we get this. So from this one we get. Now second, NO2 NaBH4. So no reduction. NO2 NaBH4 cannot reduce NO2. Cannot reduce NO2 to NH2. So it means from B we cannot form. Then first NH2, HNO2. So first we have N2 plus. Then in the presence of aniline, HCl, we get para-amino-azobenzene. We get this. Okay, bete. So option B is going to be the correct answer. Now, next question. The most appropriate region for the conversion of CH to Cl and CH3, CH2, CH2, NH2. So see, CH3, CH2, C triple bond, and NaBH4 cannot reduce, right? LiLH4 can reduce. So CH3, CH2, CH2, NH2. So it's a good reducing agent. So it can reduce. ठीक है? CH2, NH2 to sorry, CN to CH2, NH2. NaBH4 can reduce imines to amines. Imines means if we have CH double bond NH, so in the presence of NaBH4, we can have CH2, NH2. Okay, bete. So option 3 is the correct answer. Now, Hoffman bromide degradation of benzamide. Benzamide is this. Gives product A, the Hoffman bromomide degradation. On heating, we have to remove the CO, and here we are going to put NH2. Okay, this is A. A on reaction with CHCl3 and OH minus gives product B. So this is carbylamine reaction. So 1 degree amines can give this reaction, and we get foul smelling compound isocyanate. Okay, the structure of A and B, they are going to be this. Phenyl isocyanate for B and aniline for A. Now next question. Which of the following does not involve Hoffman bromomide degradation? In this R C double bond O NH2, and if we have Br2OH minus, so we have to remove this group and we should be getting this one. So question says which of the following does not involve? So see, this involves CH2 C double bond O NH2. So we have to remove this. So this though can involve. Then let's check for second one. So we have C triple bond N and KOH in the presence of H2O. So that is the basic hydrolysis, and we get COOH. Acha, ab now we can also say ki we can even have partial hydrolysis now. So we have COH double bond NH. Now this can be converted to tautomerized to C double bond O NH2 and then Br2OH minus, that is the Hoffman bromomide degradation, and we get aniline. So from this we can, matlab 1 and 2 they involve Hoffman bromomide degradation. Now let's look for option number 4. So option number 4 we have Cl, then NH3 and NaOH. Okay, NH3 and NaOH. So NH3, so what we are going to do, we are going to remove HCl, so NH2. After removal of HCl, we are going to do this one. Then again Br2OH minus, so Hoffman bromomide degradation. So last option is this. Okay. Here we have Br2OH minus, but this is halo form. Halo form. Because here we have methyl ketones. So from the first step, we get CH2, C double bond O minus plus CHBr3. Okay. So that is for halo form. So option 3 is going to be the correct answer. Now let's do next question. In the reaction of hypobromite with amide, see Br2 in the presence of suppose NaOH. Okay, so we get NaOBr. Okay, NaOBr. So this is hypobromite. So question says on reaction this with amide, so carbonyl carbon is lost as carbonate. Okay, on reaction with Br2 and OH minus, or we can say NaOBr, we get RNH2. Suppose if we have NaOH, so we get Na2CO3. Then we have NaBr plus water. So it removes as carbonate. So option 1 is the correct answer. It will not remove as CO2, it removes as carbonate. Please learn it. Next. Which of the following compounds can be prepared in good yield by Gabriel phthalimide synthesis? 1 degree amine can be prepared, but bulky group should not be present. Bulky group should not be present, or what we can say that 1 degree aliphatic amine we can prepare, not aromatic amine. Not aromatic amine. Okay. So this is 1 degree, but here NH2 is bonded to CH2. So NH2 is not bonded directly to phenyl ring, so we can prepare this. This is 2 degree, no. This is amide, no. This is 1 degree aromatic, so no. So option 1 is the correct answer. Okay. Now next question. The total number of amines among the following which can be synthesized by Gabriel phthalimide synthesis is, so obviously 1 degree, right? So this is 1 degree aromatic. No. This, yes, 1 degree. This is 1 degree. Yes. This is 1 degree. Yes. So here we have CH2, CH now. So we can prepare this, right? But this NH2 cannot be bonded with the bulkier group. We cannot prepare this. Suppose if we have this is also 1 degree, but we cannot prepare this with it. Okay, so the total number of amines we can prepare, that is 3. Answer is 3. Okay, answer is 3. Okay, now next question. Ethylamine can be obtained from N-ethylthalamide on treatment with. What is N-ethylthalamide? N-ethylthalamide is this, C2H5 on treatment with. See, if H2O है, अगर H2O H plus है और H2O OH minus, then we can use it. Then we can form. If we have H2O H plus or H2O OH minus, so we are going to break this. And when we break this, we get, we are going to break this one and C2H5, this and this. So we get double bond OH plus C2H5NH2. But we have what? Only water. Only water है तो no. NaBH4 cannot reduce. We have NH2NH2. Let's find out how we can have C2H5NH2. So see, I'm going to draw this one. Double bond O, and this is NC2H5, and this is double bond and this. So we have NH2NH2. Okay. So electron of nitrogen attacks on this carbonyl carbon, and electron of this one shifts to nitrogen. By doing so, we have double bond. Okay. Then N H H positive, and this is NH2, and we write double bond O N minus C2H5. Okay, bete. Now N minus take this H plus, and electron of this bond shifts to nitrogen. So we will have double bond this NH C2H5 double bond. Okay, NH NH2. Fine. Now what happens? Now this NH2 attacks on this carbonyl carbon, electron of this bond shifts over here. Okay. So by doing so, we write double bond O NH2 positive NH double bond O. Okay. We write this one. And we get NH minus C2H5. Now NH minus takes hydrogen. Okay. So we get double bond O NH double bond O NH plus C2H5NH2. Okay. So we can prepare ethylamine from hydrazine. How? Nucleophilic addition elimination reaction. Nucleophilic addition elimination reaction. Okay. Now moving on to the next question. Which of the following amines can be prepared by Gabriel thalamide reaction? N-butylamine? Yes. N-butylamine is this? Yes, we can prepare. Yes. Triethylamine? No. Bulkier group है ना, C2H5 and C2H5, C2H5. This is 3 degree. No. This is 1 degree. Yes. Third butylamine, CH3, 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 and this is NH2. This is 1 degree, but this group is bulky. So no. Neopentylamine, तो neopentylamine is CH3, 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 CH2, NH2. So this is also 1 degree amine, but this group is too bulky. Okay. So which of the following can be prepared easily by Gabriel thalamide? First, N-butylamine. Okay. Now next question. The major product of the following reactions. Fine. Br2H nu. Free radical. We have to do free radical, bete. So double bond O NH2. So obviously we are going to form free radical over here. So we get double bond O NH2. At this position we get CHBr and CH3. Okay? CHBr and CH3. Now we have KOH. Dilute KOH is there. But the point is that intramolecular attack is always faster. So this nitrogen attacks over here and Br leaves. So we get NH2 positive. Now CH Okay, and this is bonded to methyl group. Clear? Fine. Now Br minus can take, the Br minus can form bond with K plus to form KBr, and OH minus, we have this situation, double bond NH and this H positive, right? Then CH3. Then OH minus can take this hydrogen. Okay, so we get NH CH3. So this is going to be the final answer. And as per this, which one is the correct option? Option 3 is going to be the correct answer. Option 3 is going to be the correct answer. Okay, done. Now, next question. We have the major product obtained in the following reaction. So we have CHCl3KOH and we have 1 degree amine. So we are going to do carbylamine reaction. Carbylamine. So we write C triple bond N. Here we write N triple bond C and double bond O and this. Then we have palladium, carbon and H2. So this is the reducing agent. So reducing agent. So now this carbonyl carbon is in the conjugation with benzene ring, right? Conjugation with benzene ring. So here keto group is reduced to alcohol. So we get NH, CH3, CH2, NH2, and here we have OH. Because double bond O keto group is in conjugation with benzene ring. Conjugation with benzene ring. Okay, bete. So D is going to be the correct answer. Now next question. An aromatic compound A having molecular formula C7H6O2 on treating with aqueous ammonia and heating forms compound B. The compound B on reaction with molecular bromine and KOH provides compound C. Find the structure of A is. If you see B on reaction with molecular bromine and KOH, this is Hoffman bromamide degradation. So it means we should be having C double bond O NH2. And on reaction with Br2OH minus, we get NH2. So this is C6H7 NH2, right? Up now, this is prepared from carboxylic acid. No, carboxylic acid on reaction with ammonia and heat, we get amide. So the structure of A must be carboxylic acid. So this is benzoic acid. This must be benzoic acid. Clear? Now, next one. The major product of the following reactions. So we have CH3, CHOH, CH2, CH2, NH2. Now, ethyl formate. Ethyl formate is this. Ethyl formate. Fine. Ethyl and formate. Formic acid. This formed from ethanol and formic acid. In the presence of triethylamine, so triethylamine is going to act as base. So now, which one can easily attack, nitrogen or oxygen? Obviously nitrogen, because less electronegative. Okay, so now in the presence of base, what happens? We have CH3, CHOH, then CH2, CH2, NH minus. NH minus can attack on this carbon and OC2H5 leaves. So by doing so, we get CH3, CHOH, CH2, CH2, NHCHO. Clear? NHCHO. So we have to find out that one only. So CH2, CH2, NHCHO. So option 2 is the correct answer. Okay. Option 2 is the correct answer. Now let's do next question. NH2CH3 AC2O. Acetic anhydride. O C double bond O CH3. What is the role? Protection of amino group. So how to protect amino group? Nitrogen lone pair attacks on this carbon and this group leaves because this is the leaving group. So we get NH, C double bond O, CH3 and the CH3. This is A. Then we have Br2 in the presence of acetic acid. Both are electron releasing. Na? So at ortho position we are going to put. So here we have plus M group and here we have plus H. The plus M group resonance is more dominating effect. So we are going to put Br with respect to NHCOCH3. Okay. Ortho position. On ortho position. Fine. So we are going to have option 1 as the correct answer. Electrophilic aromatic substitution. Now, next question. Okay. Name reaction. This is very simple. So A can be matched with second Sandmeyer. Then B can be matched with Getterman. Fourth, C can be matched with Woods. And D can be matched with Fittig. Okay. Now on the basis of that, A second, B fourth, C first and D third. Third is going to be the correct answer. Fine. Now next question. Okay. NH2CH3 NaNO2 HCl. So first we have N2 plus Cl minus benzene diazonium chloride. Then Cu2Cl2 plus HCl. That is Getterman. Getterman क्या Sandmeyer भी we can say. So here in place of N2 plus we can get Cl. So here we have CH3. Now Cl2H nu. Side chlorination of alkyl benzene or CH3, right? So what we are going to do? We are going to write CH3 CH2 Cl. Okay, because free radical is formed and free radical is stable over here, right? Free radical is stable over here. Now in the presence of Na dry ether, so we have to do Fittig reaction. अब Fittig है and Woods है, so Woods reaction fast जैसे CH2Cl है, so we are going to form Cl, CH2, CH2 and this. Okay, so option 1 is the correct answer. ठीक है, Woods is better in comparison to Fittig. Next, NH2 NaNO2 HCl. So first step, we write N2 positive. Now N2 positive, it leaves. So we have carbocation formation bete. So we have positive. Now what happens? This is not aromatic. Not aromatic now. So what we are going to do? First we are going to expand ring. So when we expand ring, so we have, suppose this is 1 number, 2 number, 3, 4, 5, 6. Okay, so this is 3, 2, 1. On 6 number we have positive charge, 5 and 4. So if we do not have aromatic amine, so it is converted to alcohol. It is converted to alcohol. If we have aromatic amine, that is converted to diazonium chloride. But if we do not have aromatic, so that is converted to OH group. So option 3 is the correct answer. Fine. Now, next question. Again, very simple, right? NaNO2HCl, then KCl. So I am writing product directly. So first we have Cl. Then SnCl2HCl and then H3O positive. So SnCl2HCl, it means first gas hai. So we write C H double bond NH. And what we are going to write then? On hydrolysis. So here HH, here we write OH and OH. Now two OH are unstable on one carbon. So we get C double bond OH. So third is going to be the correct answer. Understood? SnCl2HCl है ना, HCl gas होगा पहला. Okay, so it means we have to do partial reduction. We have to do partial reduction. Then only we get CHO. Otherwise we get carboxylic acid. Essence, the amides hoga, amides on hydrolysis gives carboxylic acid. Now carboxylic acid is not in the options. So it means we have to do partial reduction over here. Now over here, again NaNO2 HCl. So first we are going to write N2 plus Cl minus, this is X. Now that is converted to OH. So OH के लिए we should be having aqueous H2SO, मतलब aqueous H2SO4 you can put, right? Or what you can put? You can put simply H2O and heat. So this is going to be the correct option, right? Why H2O and heat? Why you can put H2O and heat? If you take H2O and NaOH, so first it is converted to OH, and then in the presence of NaOH, na, we get this ONA. But we get this as the major product because we have the Dow's process. That's why H2O in the presence of heat. We are not going to use option 1. Okay. Now next question. Let's do. We have discussed this type of question so many times. I am writing the direct answer. So first we get N2 plus and Cl minus, and then we have to do coupling reaction. Coupling happens at para position. So it means option 3, not option 3. Option 2 is going to be the correct answer. Okay, diazonium plus coupling. Next, again NaNO2 HCl. So first N2 plus Cl minus, then Br, then Cu2 Br2 बच्चे. So in place of N2 plus we are going to write Br, and then HNO3 H2SO4. This is the nitration. Okay, so para and ortho, right? So it means we can put Br, NO2 and Br. With respect to one bromine, we have ortho position, and with respect to another bromine, we have para position, right? So option 2 is going to be the correct answer. Next, NO2, and we have to form this Br and Br. Okay, now here Br is over here. So first what you should do electrophilic aromatic substitution. So if I use Br2Fe, so we get NO2 and Br on the meta position. Then in the presence of HCl, NO2 is reduced to NH2 beta. Then NaNO2HCl, diazonium, and then CuBr Br. Okay, so we get, on the basis of that, fourth is going to be the correct answer. Okay, fourth is going to be the correct answer. That's it. I hope you have understood all the questions. So questions are very simple. So many questions are based on the coupling reaction and the diazonium chloride. So please go through these reactions once again. Go through the Hinsberg region test, carbyl amine test, right? These are very important tests. One more reaction, Hoffman bromamide degradation. So there are so many questions which are based on these reactions, these tests. Okay, we have done enough questions which will give you the clarity about how to solve question with respect to amines part. Rest you have to do on your own. Just go through the notes entirely and try to do as many questions if you can. Okay, so bye, take care.